Here we have the function 2 dividing by y minus x, and this time we want a power series representation. So we want a power series, a geometric power series representation of the function 2 dividing by y minus x. And again, this time we want the power series and the function to be the same for values around 1. In the other examples, we did them for values around 0. And so if we want for values around 1, then first, this is what we do. We write so first we write x with x minus 1. And so we inserted a minus 1 in here. But when we inserted the minus 1, then what we did was we added a minus negative 1 to this expression. And therefore we have to subtract 1. So we have phi minus x. And what we did was we want the x to become x minus 1 because we want values around 1. And so from here to here we inserted the negative 1. But when we inserted the negative 1 here, then what did we add to this expression? We added a minus negative 1, which is a plus 1. And therefore we need to subtract 1. And now if we do, if we simplify this, is phi minus x. So this expression is the same as phi minus x. This is phi minus x, and then minus and minus 1 is plus 1, and then minus 1. And so even whatever we do, we cannot change the phi minus x. It still has to be phi minus x. It just looks different. So phi minus x minus 1 is the same as phi minus x. So our original expression was 2 divided by phi minus x. And so now phi minus x is the same as phi minus x to minus x minus 1 and then minus 1. And now simplify. Here we have 2. 4 minus 1 is 4. And then minus x minus 1. And now this looks almost like the form a divided by 1 minus r. Except this 4 right here, it needs to be 1. And therefore we divide everything here by 4, and then divide everything here by 4. 2 dividing by 4 is 2/4. And then dividing by 4, and then dividing by 4. So this becomes 1/2. 4 divided by 4 is 1, and this is x minus 1 divided by 4. And now this is in the form of a divided by 1 minus r. A will be 1/2. A will be 1/2, and then r will be x minus 1 over 4. So now that we have a, now that we have r, we can write the power series representation for f of x. So f of x equal to 2 dividing by y minus x. We'll have the power series representation. This is a, this is r. A is 1/2. So in the place of a, we have 1/2. And then in the place of r, we have x minus 1 divided by 4. And so this power series right here, geometric power series, is a representation for this function. This is a geometric power series, and so it converges as long as r is between negative 1 and 1. In this case, r is x minus 1 divided by 4. And so this series converges as long as x minus 1 divided by 4 is between negative 1 and 1. And then we'll simplify this, or we'll solve for x. First, multiply everything by 4. Negative 1 times 4 is negative 4. 1 times 4 is 4, and then x minus 1 over 4 times 4 is x minus 1. And now we'll add 1. And now add 1. Negative 4 plus 1 is negative 3. X minus 1 plus 1 is x. 4 plus 1 is 5. And therefore this power series converges if x is between negative 3 and 5. And so as long as x is between negative 3 and 5, then the function f of x and the power series, they are the same. And so let's pick the number between negative 3 and 5. So let x be 1.5. So if x is 1.5, then f of x will be 5. For x equal to 1.5, in the place of x, we put 1.5. So 2 dividing by 5 minus 1.5 comes out to be 4/7. For the power series, in the place of x, we have 1.5. .5 minus 1 is 0.5. So now a will be 1/2. R is 0.5 divided by 4. And this simplifies to 4/7. So we have 4/7 and 4/7. So this power series right here is a power series representation for this function.